So regulatory monitors, these are surface monitors, are what are traditionally used for population level exposure. So usually we have one or two monitors that are set up in a community, and we're just going to use either that nearest monitor, or we're going to use an average of the monitors over those geographical regions in order to come up with a concentration that people are exposed to. And again, that's going to be an average concentration for that whole population. We also use satellite observation, so remote sensing are going to be able to provide a picture of the Earth and air quality. They're going to be viewing the whole atmospheric column, so they're not going to be seeing what's exactly at the surface. And so when we use those, we're generally saying, is there smoke over this area or not? Not used, again, for a measure of the surface concentration, but what could be impacting the community. I think we have a whole bunch of new exciting satellites that are going to be launched or have already been launched. And these are mainly geostationary satellites. And so these satellites are going to be over a fixed point at the Earth. And they're going to view that fixed point throughout the day. And so with these satellites, we're going to be able to really track bad air vents, specifically wildfire smoke. You're going to have really good temporal and spatial resolution. What that means is that you're going to get a picture of the Earth that's a lot clearer than what we have now, and you're going to get that more frequently. So some of these are producing these pictures every 15 minutes to every hour. So again, we're going to be able to track smoke and air pollution events much better than we have in the past. So we've done some work using social media, and so this is where we're taking people's posts either on Facebook or Twitter, and we're trying to see when are they talking about smoke and where are they talking about smoke. So I think there's a lot of promise there to take that information, not only because we can get the location and the time of when they're exposed, but we can also get how they feel about it. Are they upset about this? Are they experiencing any health effects? Are they complaining about itchy eyes or coughing? So we can get some of those short-term effects. Also, we have a lot of new monitors that are being developed. They're low cost. So usually these monitors that we have in a community are on the order of tens to hundreds of thousands of dollars to install and maintain, where we have these low cost monitors where we're talking maybe on the order of $100 to $1,000. With this price point, we're going to be able to have a lot more monitors that can be deployed. So people, especially in rural communities or people who live far away from a monitor, would have the opportunity then to see what the air quality is where they're located. Some of these low-cost monitors, they still have a lot of uncertainty, but I think they can be used really qualitatively, so that they can be able to see, is my air quality worse than it normally is, especially during, again, wildfire events. So even if they may not have the exact concentration correct, they're still going to be able to be used to see, when has my air quality been worse than it normally is. So smoke forecasts are usually trying to predict where smoke is going to be in the future, but studies have used them to look at past events. So they've used some of these forecasts and then tried to use them to say that that's actually where smoke occurred. So it can be used. However, smoke forecasts are really difficult. It's difficult to predict where fires are going to be, so it's also going to be difficult to predict where smoke is going to be. I think we're getting a lot better with our smoke forecasts, but it's always going to be that smoke forecasts are better on a shorter time scale. So if we're going to use them for retrospective exposure assessments, we want to use the forecasts that were made closest to the actual exposure time, and they're going to be a lot more useful. So when we're talking about blended methods, we're trying to use data from a whole bunch of different sources. So generally what we're using are either surface monitors, or we're using satellite observations, or we're using models. Again, these are either forecast models or statistical models or chemical transport models. So there's a whole bunch of different data sets. All of these have limitations, and so what a lot of studies have been doing is trying to combine the data from these. So if we're using surface monitors, they don't have really good spatial coverage. They're at a fixed point. but we could combine those with satellite observations, which are giving you this really broad picture of where smoke is. And so then we would be able to say, if this is where smoke was and this is the concentration at the surface, maybe this is the concentration that's over that whole region. So there are a lot of benefits, and I think most studies have shown that blending different observations can overcome some of the limitations. It's not going to be able to overcome all of the limitations. There's going to be time periods, so at night we don't have a lot of satellite observations, and so we wouldn't be able to use those to be able to predict concentrations at night. We could completely, if we had a really small fire, that might be missed by the satellite, and it may be in a region where the smoke plume can't hit a monitor. So if we're not seeing that from the satellite, we're not catching it by a monitor, then even using a blended method isn't going to be able to overcome those limitations. So there are going to be certain situations where it's not going to be overcome, but I think in general we found that using more data that's available is going to come up with better estimates. So there's visual range that is reported. They're automated at airports, and this is just trying to see how far you can see. Human-sided visual range has been suggested to be used in communities without surface monitors. And so this is training citizens to be able to look for objects at a known distance and see how much their visibility has been degraded. I think this is really useful in smoke situations if you're trying to assess the severity of the situation that you're experiencing. If I can't see the mountains that I normally see, maybe I should stay indoors, I should have my filter running, maybe I shouldn't go running outside. If we're going to actually use these for exposure assessments, it's going to be really difficult. Studies have shown that the visual range from humans isn't really well correlated with actual surface concentrations, and this is going to be partly because you can have relative humidity that's going to impact your visibility, the sun angle is going to impact it. So again, I think it's really good if we're just trying to teach people a way to assess the severity for themselves, but I think it's difficult to actually use for exposure assessment. I think if we're going to use these in communities, I think having better access to forecast models in their region, knowing where to get any kind of model data, satellite observations, and then again, low-cost monitors I think will be a really useful future step for these other communities. So I think a lot of the focus has really been very academic. We're trying to produce the best estimates for academics to use and researchers to use, and I think we need to do a better job getting this to the public. I think part of that is better development of mobile and web applications. Everybody has their favorite weather app that they use. People need to have better air quality apps. They need to know who they can trust when they're getting these observations, where to get that data. So I think better integrating with that with apps that they're either already using or developing new ones that people will know to go to. I also think that people need to be able to get the data in one place. So instead of having to go to one site to look at the satellite observations, one for the surface, one to look at what the potential health effects, we need to put all of that data together in a place that people will be able to access easily.